Let me start recording. Okay.
I see.
And I have some examples from chapter 2, but if you have like homework problems, why not?
Mm. Mm. What about like do you have that one problem, a uniform block of steel? Well, it's in mercury and then also water.
Is it from chapter 2? This one?
Yeah.
What's the problem number? Because I have the book.
Oh, I have or is it the connecting? Let's see.
Yeah, you can share your screen, I think. Yeah, you can share your screen and we'll start working on the problem.
It says host disabled, participant screen sharing.
So always have, okay, now I think you should have permission. Mm-hmm.
Yep. Oh, is this blocking it?
Oh, I see it now.
Okay. Yeah, it's
So we know we're dealing with the buoyant force, right?
yeah.
Okay.
Let me see if I. Yeah.
So it is problem 2.122 in the textbook.
Oh, okay.
Okay. So oh, I saw you solved the problem already.
Oh yeah, it's just not gonna lie, I use check.
Oh, okay. Okay. So do you have any questions specifically, or should we go over it from the top?
Yeah, I was just gonna go over it.
Okay. So let me see here.
Wait, what the heck? Stop sharing. There we go. Yeah, chapter 1 and 2 don't seem too bad for fluid mechanics.
Yeah, they should be the easiest chapters,
Yeah.
right? 2 and 1. Then 3, we jump into fluid dynamics,
Yeah.
and it kind of gets harder from there.
Yep.
Okay, so let me try to share my screen. Okay. Open this one, and then so we have, let me see the book. So we have water. So this is problem 2-122. And you have water and mercury and a steel block. So this is water
Yeah.
and this is mercury, Ag, and the specific gravity is given for mercury. It's 13.56.
Mhm.
And it's asking us to find will float at a mercury. Okay, what is the ratio of the distances A and B for this condition? Okay, what, like, how would you approach this problem? It's telling you it will float, and that means what?
Well, I think. Wait, let me see. It will float at a interface. Uh, I think. Well, you would do a free body diagram first, right?
Yeah, you would do a free body diagram, and how would you draw this one?
It would be.
So let
It
me.
would be the
Here's the.
buoyancy force. Oh yeah, it'd be the weight of the weight of the thing, right?
Yeah, of course. You have weight of the steel block,
You have the buoyancy force from Mercury,
and you have the buoyancy force from Mercury.
and then I guess you would have the weight of the water. Uh, is it? Uh,
You'll have also the
or is that
buoyant
the? Yeah,
force
yeah,
from the
yeah,
water, right?
yeah. That makes sense.
So these two fluids are trying to push up on this steel block, and the
Yeah,
weight is kind of dragging it down.
yeah,
So
I
you
see.
have two or three forces in total. So
Mm-hmm.
FB, and let's call it W for water. Good?
Yeah, that makes sense.
Okay, great. So if you want to write, hold on,
Oh
what
wait,
was,
they're both. Wait, so they're both gonna push forward or like straight up like that?
yes, they were both trying to push the block up.
Oh.
Because remember, if we have, like, imagine we only have water, we don't have the mercury.
Mm-hmm.
What's going to happen? You're going to have the weight of the block
Mm-hmm.
and the buoyant force from the water. The only thing we're changing in this problem, we're adding a second fluid, which is mercury. So both fluids, water and mercury, will push up on the block. Did I?
Oh, okay. Okay.
Does this make sense?
That kind of makes sense. Okay.
Yeah, both fluids will try to resist the motion of this block. This block
Mm-hmm.
has a weight and it's sinking, so both fluids will try to push this weight up,
I see. Oh, yeah. That makes sense. Okay.
right?
Yeah.
I
That
mean,
makes sense.
what were you thinking? Were you? No, what I mean,
Yeah, I was just thinking.
some like
Okay.
water is
Because
trying
I
to
guess
push it down.
okay now that the way you're explaining it, it's kind of like it has a bottom, right? The water has a bottom where like we're no wait no. Okay. I was just thinking about the gravity all wrong. Okay, no, it makes sense. It makes sense.
No, I
I was
mean,
just thinking that.
yeah.
I was thinking like, wait, wouldn't since the water's on top of the thing, like, wouldn't it be pushing it down? But no. I mean, yeah. But then I guess it's because the water is also being pushed down by gravity. Then it just kind of like pushes the thing up, or I don't know.
Yeah, well, if you're saying the water is pushing down on the block,
Yeah.
that is what? That is hydrostatic force now, right? But remember, buoyant force is the net force acting on the block,
Mm.
right? Sometimes, like, yeah, when when we solved the problem with the submerged steel ball on Sunday,
Yeah.
right? Why did we not account for the hydrostatic forces and pressures? Because the buoyant force is the net force of all these stuff. So once you
I see.
consider buoyant force, you don't have to consider the water pushing down. Of course, the water will try to has the block will experience some static hydrostatic force from the water,
Mm-hmm.
but in this example, we're considering buoyant force, which is the net force, right? Because the pressure at this location on the block, so let me use red pen, will be less than the pressure here if it was completely water, no mercury,
Mm.
right? So the net force will be the buoyant force.
I see. Okay, that makes sense.
Yeah, I think this is where it gets confusing. But yeah, once you deal with buoyant forces, just don't include any pressures and hydrostatic forces, and because buoyant force is the net force.
I see.
Okay,
so
good.
yeah.
Okay, great. So you wanna write the summation of forces in the y direction now?
Yeah. Yeah, it would be summation of forces in y direction equals to 0, and it would be what is it? The buoyant force of water plus the buoyant force of mercury minus the weight of the steel block equals 0.
Okay, great. So how would you find the weight of the block?
Weight of the block. Let me see. Uh,
Remember
oh, it
what's
gives specific gravity. It's it's 7.85
the
for yours too,
specific
right?
gravity for steel? Yeah, is 7.85.
Yeah. Oh wait, so when you were thinking about finding the steel blocks, what is it? The weight? Were you thinking about something else? Like if they hadn't given specific gravity, do you just like
If no specific gravity is given
do you
for a
just like use a
steel
cable or
block,
something? Yeah.
what do you use?
Do you just like can you just like look that up, or is that like
Yes, I think you have to look that up because I don't know the density for steel.
mm-hmm. I see.
You have to look at tables.
Okay, so then to find to find I think the density of it, you would have to do it's 7.85 equals to
So Sg of steel is
equals to
equal to the density of what?
density of steel
Steel, yep,
or density of water, I think.
over density of water. And once you cross multiply this entire thing, so you'll end up with the density of steel is equal to a calculator here. So it's 7.85 times what's the density of water?
1,000.
1,000
Yeah.
or
Oh
998.
yeah.
Or let's use 1,000, that's fine. So 7,850. And what's the units for this one?
It should be uh, is it kilogram over meter square or it's cubed?
Meter cubed, yes, because it's mass over volume,
Yeah.
right? So, okay. So if we go back to weight, what's the definition of weight? It's mass times gravity.
Yeah.
Gravity is constant,
Mm-hmm.
9.81. We can assume it's constant. What about mass? How would you find mass from density? You know the density, you need mass.
You just calculate. You multiply uh, mass by the what is it? Wait. What did you say? Sorry, I just blanked out for a sec.
Yeah, no problem. So you have density. We just
Yeah.
calculated it.
Yeah.
We need mass. How would you find mass?
Oh yeah, you just multiply the density by the volume
Volume,
submerged.
exactly. So you can get rid of this meter
Oh
cubed
yeah,
and you'll
not
end up
submerged.
with kilograms.
Yeah.
So,
Volume of
okay.
the steel block,
So,
uniform steel block.
so weight is equal to what? Density? We said density of steel
Yeah, multiply by volume.
multiplied by volume of steel
Yeah.
times what? We're missing one term.
Really? Oh yeah. Gravity.
Gravity, yes. So this term right here is mass.
Yeah.
Okay, well, we know the density of steel. Do we know the volume of the steel block?
No.
We're trying to calculate the volume, right?
We're trying to find the ratio between A and B. Yeah, I don't think we could calculate the volume with the information given.
Yeah, we can't, but I mean, we can find the ratio between A and B. So
Hmm.
this volume will be variable in our equation,
Okay.
right? So let's, how would you calculate FBW, or the buoyant force from water? What's the equation or
It
formula?
was gamma times volume submerged, right?
Gamma of water, right?
Yeah.
Times the volume of the steel block,
Hmm.
only the portion submerged in the water, right?
Yeah.
So steel and water
Hmm. And
plus gamma water times the volume of the steel submerged in mercury. Or no, this is gamma mercury, right?
yeah.
Yes. Okay, minus, we know this one, it's gamma steel or dense rho steel
Yeah.
times volume. And is
Mhm.
this the entire volume of the thing?
Yeah, that's entire volume.
Yes, it is the entire volume. Times gravity is equal to 0. Okay, let's highlight everything we know in this equation. Do we know the gamma of water? This one? Let me use a highlighter. This one, do we know gamma of water?
Oh yeah. Gamma
Yes.
water should be the density of water times gravity, right?
Yes. Do we know gamma of mercury?
We could calculate it.
From what?
The specific gravity of
From
Mercury.
exactly. You can calculate it from specific gravity. Do we know density of steel?
Uh, yeah, we just calculated it.
And what else? We know gravity.
Hmm.
And what's our variable in this problem now? If you look at the equation,
Oh, I guess the volumes.
volume. Yes, exactly. That's how you solve the problem now.
Hmm. I guess. Okay, so it would be like the volume of steel within water plus the volume of steel within mercury equals the volume of the entire thing, right?
Yes,
Something
yes,
like
the
that. Yeah.
volume. Yes, if you combine the two volumes, you should end up with the volume of the steel,
Mm.
entire steel block.
Okay, that makes sense.
Okay, so if we expand this one, let's leave it as gamma of water.
Yeah.
And how would you find the volume of steel of the like portion submerged in the water? Only
Oh,
that portion. It's a steel block.
yeah. That would be A.
What
Just
is A? Oh, A is, yes, you're correct. Yes, it is actually A
hmm.
times what? What's the volume of a cube? Or not a cube in this case.
It just says block.
It's a block, right? So it
Yeah.
has width, length, and height.
Mm-hmm.
So if you multiply these three, you'll end up with meter cubed, and now you have volume.
Yeah.
So we know A.
Yeah. I don't think we
Okay.
know the other ones.
Uh, are they really necessary in this problem?
What do you mean?
Do they have to give them, like, to give us the dimensions of the length and what else are we missing? Width?
Oh, yeah. Well, I guess not, but I'm not
Yeah.
sure. But wouldn't
So
you need it though? I don't know.
okay,
Like they
let's,
didn't give it, so I
yeah,
guess not.
I mean by looking at the problem, okay, let's assume we need these three lengths. We need the width, we need the length, we need the height. So how
Yep.
would you calculate the volume of steel in water? You said A, which is the height,
Yeah.
times
The width and the length.
width and the length. So let's call, what do you want to call the width? So width is this.
W. Oh, I get it. Oh, it's
That's
because
the
like
width.
it's because the other volumes will have the same exact width and length.
And they will
Okay.
cancel,
Ah, yeah.
right?
Yeah.
Well, yeah, let's write it. So it's A, you said W for width. What about length? We need the
L.
length in the board.
Yeah.
So A times W times L. Does that
Yeah.
work? Okay. Times gamma Hg times the volume of steel.
BWL. Yeah.
BWL, exactly, yes. I think now you see what's going on in this problem. And then this is easy, rho steel. What about the volume of steel?
That would be A plus B, like with parentheses and then the WL.
Exactly, yes. Yep, that's the entire length. You add the entire height with the width and length.
Yeah.
And then times gravity,
Yeah.
which is a constant, and it's equal to 0.
Mm-hmm.
Okay, now what do we see in this one? We have 3 terms, right?
Yeah.
This is the first term, second, and third. And what do they have in common?
WL and I guess also G if you want.
Yes, that is actually a good observation. They do have G in common, all of them. So if we scroll here, you'd see that this is just density of water times A plus density of mercury times
Mhm.
B minus density of steel times what?
Oh, A plus B.
A plus B is equal to 0.
Yeah.
And why is that possible? Because you can factor out G times WL.
Yeah.
And how can you get rid of this one? Just divide the entire thing by GWL. This will be 0.
Mm-hmm.
So do we actually need the length and width?
No.
Not really. There, we call this problem, it's independent of the width and length.
Mm. Okay.
Okay, and now yeah, you just plug in values and try to solve for the ratio. We're not trying to solve for each specific, so we know the ratio, we don't know the specific value for A and B. We just know the ratio.
Mm-hmm.
So you can manipulate this equation. We know the density of water.
Yeah.
Density of Hg, do we know that? Did we calculate density of Hg? I thought we did. Okay, so how would you find density of Hg?
We have the specific gravity given. It'd be specific gravity of Hg equals to density of Hg over density of water.
Exactly, and you cross multiply, you'll end up with the rho Hg
Mm-hmm.
is equal to, what's the specific gravity? 13.56 times 1,000.
Yeah.
That's 13,560. The units for density is kilogram per meter cubed.
Mm-hmm.
Good?
Yep.
You can see how dense this mercury is.
Yeah.
It's 13.56 times more dense than water. It's crazy. But okay, what else? So we know this one now. What else? We know the density of steel, I think we can, yes, it's 7,850. And now you can solve for the ratio,
Yeah.
right?
Mm-hmm. Yes. That's good.
Good?
Yep.
Okay, you want me to go over the numbers and stuff, or are you want me to continue, like, find the final answer?
Oh no, that's good.
That's good. Okay,
Yeah.
so here's your equation. This is, we actually, based on the problem, we derived this equation.
Yeah.
So here's your equation. After doing all this what do you call it? Summation, not summation. It's just manipulation with the formula. You'll end up with just all you need is densities and the ratio, and that's it. I can solve the problem.
Okay, that's good.
Okay. Hopefully that's helpful.
Yeah, that is.
Good. Okay. And anything else you want to see? Any other problem, maybe?
Yeah, there is a problem my professor gave me, but I haven't really had the chance to solve it yet.
Well, let's see. Maybe we can help each other.
Okay. Let me see. Yeah, let me just try to screen share it. It says I can't screen share while another
Oh,
participant is also screen sharing.
let me. Okay, I think I have to end it from my end. Let me stop. Yeah, I think now you can screen share. Okay, inside a pressure tank reads 12 psi. Okay, another Morgan gauge B outside the pressure tank reads 20 psi. Okay, let's take a look at this problem. So we have what? We have a pressure gauge,
Yeah.
right? A inside the
Two of them.
pressure tank,
Yeah.
and that's A, and it's reading 12 psi inside the
Yep.
tank. And we have pressure gauge outside the tank, which is B, and it's reading 20 psi.
Hmm.
And we have a barometer that is reading 29 inches. Oh, so it's reading 29 inches of Hg, so we have to convert that to psi, right?
Yeah.
Because we can measure pressure actually with inches of mercury, just like you measure your blood pressure with millimeters of mercury. So what is the absolute pressure measured by A in inches of mercury?
Wait.
Well, if we're looking for inches of mercury, so convert psi to inches of mercury. I think that's even better. Right? Because we need the final answer to be in inches of mercury. So maybe 12 psi. We can Google that 12 psi to inches of mercury, which is 24. So 12 psi is equal to 24.43 inches of mercury. And we have 20 psi, right? Yeah, 20 psi. And that one is 40.72 inches of mercury. Okay. What else do we need?
Wait, so it says what is the absolute pressure of A in inches of mercury? So, well, since you already converted 12 psi to inches of mercury,
Mhm.
isn't that already the answer? Or
Okay, a pressure gauge measures gauge pressure. It doesn't measure absolute pressure, right? So if you stick a pressure gauge in your car tire, you
yeah,
would get a reading. For example, in my car, it's 36 psi. What is that? What is that reading? Is that absolute pressure or is that gauge pressure? If you
I
just stick a pressure gauge in your car tire and you get a reading.
I guess it's just not absolute, right? It's
It is actually gauge pressure,
yeah, gauge, yeah.
right? If I want to find the absolute pressure, I don't think people will deal with absolute pressure when they talk about their car tires, right? They don't say, "Oh, my absolute pressure is 40 psi" or
Mm-hmm.
something. No, they say 36 psi. They just imply it's gauge pressure,
Mm-hmm.
right? So all I have to do if I want to convert from gauge pressure to absolute pressure, what do I
Yeah.
have to do?
Hmm. I'm not sure.
So let me share my screen.
Hoi.
Trying to share. Okay. So let me, okay, hopefully you can see my screen. And for example, I'm standing, right? And at sea level,
Yeah.
let's assume I'm just watching the ocean. I'm holding a pressure gauge in my hand. What should the reading on the pressure gauge be if I'm at sea level, right at the ocean, right? What's my reading on pressure gauge?
When you're at the sea level,
Yes, at sea level.
uh, I'm not sure.
It would be 0, right? There is,
Zero.
yes, it would be 0. You're open to the atmosphere and you're not standing in a mountain or down at the valley. You're just standing at sea level and holding a pressure gauge. You should read 0 psi,
Oh,
almost 0 psi. It's not perfect, right?
at the sea floor, you said.
At sea level.
Oh, sea level. Oh, I see.
And okay, I'm measuring,
Okay, okay,
well,
that makes sense.
does that mean there is no pressure at sea level? Because I'm holding a pressure gauge and it's reading 0. So I'm going to
Mm,
say, okay, there is no pressure at sea level. I'm in
mm.
a vacuum. Well, no, you're not in a vacuum, really. Because if you're in a vacuum, you're not going to survive, really.
Yeah.
So there is pressure. And what is that pressure? It's called absolute pressure. So you have 14.7 psi acting on you at sea level.
14.7. Okay.
Yes, so the ambient pressure or the atmospheric pressure, or they call it like, it has so many names, it's crazy. It's 14.7 at sea level, psi.
I
So
see.
let me write the formula for you. So P absolute is equal to P gauge plus P atmospheric.
Mm,
So going back to our car tire example, I'm sticking a pressure gauge, it's reading 36 psi.
mm-hmm.
Okay, the gauge pressure is 36. But if I asked you, okay, what's my absolute pressure in that car tire?
Yeah.
You would say what?
Oh, you'd have to
I'm at sea
add the
level.
atmosphere. Yeah.
Yeah, I'm at sea level. Let's assume perfect conditions,
Mm-hmm.
no hurricanes, nothing. It's just perfect condition.
Mm. Oh, then you'd add 14.7,
7.
right?
So I would tell you, okay, my absolute pressure in my tire will be 50.7 psi,
I see.
which is kind of dumb. Nobody says that, right? Everybody deals
Yeah.
with pressure, gauge pressure. Nobody deals with absolute pressure.
Mm-hmm.
But yeah, some problems, yeah, we will deal with absolute pressure like this one.
So for this problem, it is assuming like sea level and perfect conditions. Or
Well, I think the problem mentioned something 29 on a barometer. If you can go back, should I stop sharing, or you can pull up the problem and tell me what's the barometer reading?
let me see. Oh yeah. It says an aneroid barometer reads 29 inches of what is it? Mercury.
29 inches of mercury.
Mm.
And what's the problem asking us to find?
The
Forgot.
absolute pressure measured by A in inches of mercury.
Okay, great. So A is this, I think it was this pressure gauge. That's A, and this
Yeah.
is B.
Mm-hmm.
So pressure at A will be what? And that's the absolute. We want to find the absolute pressure at A. What's the
It'd be,
formula for absolute pressure?
it will be. So wait, this is assuming like seafloor and all that, right?
No, still we have a barometer that's reading 29 inches. I don't know what's 14 psi
Mm.
in inches. Let's see if it's actually at sea level. No, not pascals, into inches mercury. 29.9. So yes, it's we're kind of at sea level, kind of.
Wait, how did you tell that we're kind of at sea level?
So the barometer is reading what, 29 inches mercury?
Yeah.
Convert 29 inches mercury, that's what I did right now. 29 inches mercury to psi,
Yeah.
and we get what, 14.7 or 14.3.
I see. That's
So
pretty close.
we're, if you have a pressure that's 14.7, really, or 14.3, you're kind of at sea level.
Mm-hmm. Okay. I think it would be 12 plus, what is it? 12 plus 14.7, right? Or
Yes, it's actually 12 plus, so 12 psi, that's the gauge pressure at the at point A, plus the atmospheric, which is I mean, I would say it's 29. I would say it's like this, but I'm not sure. I'm not sure about that, but I think it's just gauge pressure plus the because I think barometer always measures absolute pressure. Let's see if I might be mistaken. Yeah, I might be mistaken by looking. Okay, I'm just reading about the barometer right now.
oh.
Yeah, see, a barometer has a sealed metal chamber that expands and contracts depending on the atmospheric pressure. Yes, so I think it does. It does measure absolute pressure. It's not like a pressure gauge. Pressure gauge does not measure absolute pressure, but
But the
a barometer does.
oh, okay. Hmm.
You know how it looks like, the one with mercury? You know how a barometer looks like? Want me to
No.
show it to you?
Yeah, sure.
Let me share my screen, and hopefully you see the book, right? I think it is in this one, in this section. Yes, that's an ancient barometer right here. Okay, you just fill a bowl with mercury, right?
I see.
And what is happening? You stick like a very thin tube into this mercury. And if you put it at sea level, this ball, the hydrostatic pressure from air, right? Because remember, there is air around us. So it will push down on the mercury, and this will go up in the tube. And that's how we measure inches of mercury, right? That's the height right here. That's why sometimes we measure pressure with the inches, right? It's just kind of weird. You measure pressure with the inches. So I'm assuming that's the problem. It's just 12 plus the atmospheric pressure, which is 29 inches mercury. And you'll end up with 41 41 inches. Is it good? Are you following or?
Wait, so you said a barometer measures like
Yeah, see right here?
measures it by inches?
Yes, it does.
Measures the pressure.
Of course, now you have digital stuff, right?
Yeah.
Of course, you can convert inches to pascals to whatever you want, but the ancient one, like this one, it tells you right here, a barometer measures local absolute atmospheric pressure. So it does, a pressure gauge does not measure absolute pressure, but a barometer does.
I see.
Right, so if you, let's assume we're using this device. We're standing at sea level, I put this device on the ground, and then the inches of mercury rises here. Okay, we say it's 29 inches. How would I find pressure? So we already found pressure, 29 inches of mercury. But all I have to do is multiply this H times gamma of air. You will end up with PSI.
Gamma of air.
Yes, because what is pushing on this mercury? And you have a bowl of mercury. Air is pushing, just like air is pushing down on me right now. It's pushing at 14.7, assuming I'm at sea level. It's pushing down on me by 14.7 PSI.
I see.
Yep. Yes. So that's the case. In here. That's why we can't survive, actually, if you go to a vacuum like space. Well, space is not a perfect vacuum, but if you go to space, yeah, you can't survive because our body is, what do you call it? It's used to having like 14.7 PSI pushing down on us.
So what would happen to the human body in an almost vacuum?
Oh, I see, like crazy. I watch crazy movies. I don't know if that's like actually true.
Yeah, because I've
a
seen
movie.
I've seen
And it's
different
just
stuff. Some people say you explode.
yes,
Like that.
it's your body trying to, because right now 14.7 PSI is pushing down on me, and my body is reacting. It's pushing 14.7.
Yeah.
That's why I'm in equilibrium.
Mm-hmm.
So if you go to space, nothing is pushing down on you, and you're trying to push 14.7. That's crazy. So I don't know. I watched like some crazy stuff. Maybe you explode. I don't know. Well, 14.7. Yeah, that's. But yeah, that's the thing with a barometer. That's why I think the problem mentioned it's actually a barometer is not a pressure gauge. Otherwise, we can't solve the problem. But you can try asking your professor. Maybe do you have like the final? Do you have the solution actually, or? I think this is 41 psi. That's your absolute pressure.
So the answer was just to add 12. Wait, how did you solve it again? Can I see the
yes,
problem?
Let me share my screen here. Can you see my screen? Or oh, forgot to stop sharing here. Can you see my screen now?
Yeah.
Okay, so we know the pressure gauge is 12.12 psi. We converted 12 psi to inches of mercury.
I see.
How? Using Google, really.
Yeah.
Okay, and then we do what? The problem tells us there is a barometer somewhere outside the tank, and it's reading 29 inches.
Yeah.
So we know that a barometer does in fact measures absolute pressure. So we know that the absolute pressure is this.
That's absolute. Does that mean that it doesn't matter if it's inside or outside the tank?
If it's inside or outside.
Yeah.
Yeah, but I'm looking at the problem name now. The pressure gauge is less than the absolute pressure. Right? Is that your question? Yeah. I just noticed right now. Yeah, maybe you need to subtract in this case, because it is in fact less than, yes, so it's trying to suck air. It's a suction, basically. Yeah, I don't know about that one. Yes, I know you have to, that's how you solve the problem, but I'm not sure now if you need to subtract or add.
That's fine. It's a pretty weird question.
It is, it's actually pretty fun, yes. If the professor like posted a solution, I would like to see it actually.
Yeah, I don't think he posted a solution.
Oh, there is no solution. Okay, you guys did not ask him during lecture?
Guess not.
Oh, okay. Well, if he does or he mentions the answer,
Yeah.
I would like to know if you can send it to me over Discord or because I'm just like, yeah, I'm kind of curious actually. But I think this is like how you solve the problem. You have a barometer measuring absolute pressure, and now you have a pressure gauge. But always use the pressure gauge is higher than the absolute. That's why we add them. But in this case, do we add or subtract? I'm not sure.
Yeah.
I can read more about that and text you on Discord. Maybe I'll try to read on some articles on stuff and try to text you like, okay, maybe we subtract, not add.
No, that's fine. I'm good.
Because right now I'm really curious actually.
Oh.
It's a really good practice problem. Other than this question, anything else I can help with?
I just have like one question on let me screen share.
Oh, I think you can, right? I gave permission. Yes, I think you can.
So for this problem, right? How do you find you're supposed to multiply like I think it was gamma by like the area and then also the center of gravity, right?
Yes. To find force.
Yeah. So how do you find like the height again? I forgot. I think it was is it like the
I mean, where are you trying to calculate compute the horizontal and vertical water forces on the curved AB? Okay, so for the horizontal one, you need H, right? HCG. Right? Which formula are you talking about?
Oh, right. Because yeah. Wait. Corner.
Pipeline labeled AB. Okay. You have a quarter circle piece of a PVC pipe. Compute the horizontal and vertical water forces on the curved panel. Oh, okay.
Wait, let me think. Here we go. So when you try to compute like the hydrostatic forces on the curved panel,
you split them.
What heights are you supposed to use? Because I know like, so wait, do we have to set like? I remember last time when we were doing the equation, we found like the centroid of the body of water. Remember?
Yes.
So do we do the same thing here?
Yeah.
So this water is okay. Well, it's 3 meters long and then 9.5. Okay, so that's kind of confusing.
What's confusing? You're trying to calculate? Remember, we have to split the forces into horizontal and vertical.
Yeah.
So the body, how would you calculate this horizontal force acting on the body of water? You would move hCg, so you'd move 2 and 0.5, right? That's how you calculate, because the entire height is 3.
Yeah.
And only the curved PVC pipe is 1 meter, so you'll move just half a meter, so 2 plus 0.5, which is 2.5.
I see.
That's how I would do it.
Okay, and that's for the horizontal water force, right?
Yes, that's for the horizontal. The vertical will be this small quarter circle, right?
Yeah.
The water, but remember there's water on top of it too.
Yeah.
So make sure you account for that. It's not open to the atmosphere at the top. No, there is water on top of it. So account for that in your calculation.
I see. Okay. Well,
but
thank you.
You want me? I can go over it on Discord. Maybe I'll try to solve it by hand, and maybe send the solution if you want. Because this is already right. You're already done with the homework. I'm not trying to solve your homework, right?
Yeah.
You're already done. You already submitted.
Yeah.
So I can solve it by hand and try to be as concise as possible to the solution. Just to have it on Discord.
Oh yeah, that's good.
Maybe you can see, and maybe you can ask me questions like on Discord too, because Discord is pretty good actually.
I think I already added you on Discord.
Yeah, I have you on Discord.
Yeah.
So sounds cool?
Yeah. Okay, thank you.
Okay, no problem. Hope you found this helpful today.
Yeah, I did. Sorry, I'm just kind of I am kind of unprepared for.
Oh
no, sorry.
No problem. It's just if you have a good grasp of chapter 2, believe me, you'll just cruise through chapter 3 and 4, because like fluid statics is kind of easier than fluid dynamics. Fluid dynamics, you have so many variables, it's crazy.
Yeah.
But for fluid statics, yeah, if you have a good foundation, you'll just have an easier time in fluid dynamics.
Okay, thank you.
Okay, no problem. Have a good one.
Bye.
Bye.